I'm going to go through the solution to problem number 30 from the quarter test review. This is an actual free response question from an AP exam. I don't remember what year, but anyway, this is one of the released items. They give you a velocity function. They ask you to find the acceleration when t is equal to 3. This would be a pretty easy one to find by hand. Remember, acceleration is the derivative of the velocity function. So in this case, we're finding the derivative of velocity. Derivative of -1 is 0. Derivative of e is itself, except notice the inside function has a -1 derivative. So I have to apply the chain rule there. That's going to be my equation. I'm going to be substituting in 3 for t. And so anyway, we have negative e to the 1 minus 3 power. That would be negative e to the -2 power. Remember, a negative exponent is the same thing as a reciprocal, so I could also write that as -1 over e squared. On a calculator, of course, you could also run that if you're in a calculator section, and you can get a decimal equivalent, but this one actually can be done without a calculator. This question asks if the speed is increasing or decreasing at t equals 3. So normally we think, oh, if something's speeding up or slowing down, we think of that as being a change in the velocity. And so the instinct that people normally have is, hey, if the acceleration is positive, I'm going to be speeding up. If the acceleration is negative, I'm going to be slowing down. And you have to be careful because it's not that simple. If you remember, when you have velocity moving in a positive direction, and the acceleration moves in a positive direction, the acceleration is making the velocity more positive. That would be speeding up. But likewise, if you've got a negative velocity and you're going to the left, if the acceleration is also going in the negative direction, it's going to make the velocity more negative, which would actually be speeding up as well. If you go from -40 miles per hour to -60 miles per hour, you're farther from zero, your velocity is farther from zero, that's a bigger speed, okay? It's a smaller negative number, but it's farther from zero. It's a positive value, it's larger. So the speed is increasing if the velocity and acceleration are both in the same direction. In other words, if they're both positive or if they're both negative. If the acceleration is opposing the velocity, if you have a positive velocity and a negative acceleration, you'd be slowing down. If you have a negative velocity and you have a positive acceleration, so maybe you're going -60 miles per hour and it takes you to 40, you have a positive value added to that, -60, and it goes up to 40. If the acceleration is going the opposite direction of the velocity, you're going to be slowing down. So that's what we're really trying to figure out here. So we should be able to look at the signs of both of these. And this is a t equals 3, and we already did this before. Notice that the acceleration is negative, okay, based on what we found out in the first part, -1 over e squared. So we just need to check and see what the velocity is here. The velocity when t is equal to 3, the velocity is going to be -1 plus, let's see, that's 1, that's plus e to the -2. Remember, e to the -2 is not negative, it's 1 over e squared. And e is bigger than 1, so this actually should be 1 over something bigger than 1. This is less than 1, and we're adding that to -1. So the velocity is actually going to be negative again. If you don't trust me, you can use a calculator to do that. So my velocity is also negative. What this means, I've got a negative velocity, I've got a negative acceleration, that means I'm speeding up, okay? So the speed is increasing there, and again, your justification would be something like you have a negative velocity and a negative acceleration. Since the velocity and acceleration have the same sign, you're speeding up, okay? A direction change. A direction change is going to happen when the velocity is equal to 0, or potentially it can happen when the velocity is equal to 0. Remember, it won't necessarily, I could have a positive velocity, I could go to 0, and I could have a positive velocity again. But there's the potential to have a sign change here. So what I'm looking for here is places where the velocity is equal to 0. So v of t is equal to -1 plus e to the 1 minus t power. And I want to figure out when that velocity is equal to 0, okay? And anyway, I'll erase a little bit of this here. Anyway, I can solve this equation. Basically, you can add -1 to both sides. You're going to get 1 equals e to the 1 minus t power. If you think about it, anything taken to the 0 power is equal to 1. Okay? So what's going to make that exponent 0? That would be t equals 1. Okay? So that's the place where I potentially have a change in direction. Okay? So now I need to find out, does the velocity change from positive to negative at 1, or does it stay the same? And so if we look up here, the velocity at 1 would be, actually I need to look at values above 1 or below 1. So for example, if I check the velocity at 0, for example, that would be -1 plus e to the first power. E is bigger than 1, so that's going to be positive. So I have a positive velocity at 0, okay? Then I need to check something past 1, okay? So at 1, the velocity becomes 0, and the question is, does it become positive again after that, or does the velocity go negative? So I'll check the velocity at 2, okay? That would be -1 plus 1 minus 2, that's e to the -1 power, which is 1 over e. 1 over e to the first. That's less than 1, so we're going to get a negative there. So there is a sign change. The velocity changes from negative to positive at t equals 1. And so, again, the time when the velocity, when the direction changes is going to be when t is equal to 1. I think that's 1 second, if I remember the units on the problem correctly. Okay? The last part, we want the distance between 0 and 3. Note that's distance, not displacement. So we're going to find the absolute value here of the velocity function, -1 plus e to the 1 minus t power, and we're going to find it between 0 and 3. Now I have a feeling this was probably intended to be done on a non-calculator test. We basically know that the velocity is positive up to 1. So if you're doing this by hand, you would find the integral from 0 to 1, and that would be your positive velocities. Then you would find the integral from 1 to 3. Those would be your negative velocities. So you'd end up with a negative displacement. You could just make that positive and you can add the two together. This time I think I'm just going to go to the calculator and do this. Integral from 0 to 3, -1 plus e to the 1 minus t power, and we get a, okay, the displacement is negative. I just typed the displacement into my calculator, which is probably not shocking because everything after 1 second, the direction, the velocity has become negative. So it's going at a negative velocity for longer. Let's see. But if I want to find the distance, I have to do the absolute value here. And that's approximately 1.854. Maybe you've got to go to 3 places for AP. And let's see what the units are there. Actually, no units given there. So I'm done at that point. The last problem I want to look at is problem number 31 from the AP, or from the quarter test review. The first part here, they give you a velocity function. They tell you the position when t is equal to 0. They ask you for the acceleration at 4, so I just took the derivative of the velocity function. I got about 0.714, not much going on there. The change in direction is going to happen when the velocity changes sign, and specifically that's going to happen potentially when the velocity is 0, okay? So I've actually graphed this on the graphing calculator. I set the velocity function, the natural log of t squared minus 3t plus 3 equal to 0, and trace this on my graphing calculator, and I'm looking at the range of values here. Basically, the function is doing something kind of like this. It comes down, it crosses here, and it goes back up. So I'm using the 0 function on my calculator, tracing a little bit, and it actually takes place at 2 places. One of the places here happens at a t-value of, oh, actually exactly 1. Okay, and I guess that makes sense because we want the natural log to be 0, and the natural log of 1 is in fact 0. So that gives us one place. So that happens at 1. And then the other place here, if I trace on my calculator, let's see here. The second point is going to happen when x is equal to 2, okay? Or when t is equal to 2 in this particular case. So that's where this changes direction. And again, you can see here the velocity is positive, then it's negative, then it's positive. So that's the primary thing you need to be able to do there. The last part D, asks me to find the average velocity of the particle over the interval. Oh wait, skip part C. This asks me to find the position at time t equals 2. I don't know how to integrate this. The derivative of the inside function has a 2t and a -3 in it. I don't have that. But I can view this as an accumulating function. I'm starting out at a position of 8 when t is equal to 0. So I start out at 8. I'm accumulating change of the velocity. And I need to accumulate this change over the time period from t equals 0 to t equals 2. And so basically I can fill that into my integral there. And that'll take care of it for me. And so anyway, if I do that, 8 plus the integral of, from 0 to 2, of the natural log of t squared minus 3t plus 3 should be equal to approximately 8.369 if I round to 3 decimal places. And then part D asks me to find the average acceleration, or no, it asks me to find the average velocity from 0 to 2. So the average value of the function is just the integral over that time interval divided by the length of the interval. So I'll take that integral there. That integral there is going to be 0.368617. I'm dividing by 2. And the average velocity, whoops. A little bit of rounding here. It's approximately 1.84 is my average velocity. So it's just the average value of the velocity function. And that's it for the quarter review.